Mario here to help us. Let's back Mario up. Here's Mario. This is one of the favorite games of all time. If you notice right there, he came out of the gate, and we have an immediate translation. Here we go. Here he goes. He's going across the screen. So as he goes across the screen, he's just sliding. His image is sliding across. Okay, so that's a translation. He goes through, he does some hitting here, blah, blah, blah. Okay, notice at a certain point when he gets to the middle of the screen, it's the background that starts translating. He doesn't move anymore. The background starts translating to the left. Okay, let's watch that again. So someone had to sit down on a computer and they had to figure all this out, and they had to type in different rules with translations. Look at the background moving there. All right, what do we have coming up here? Anybody know? He's going to get the mushroom. What's going to happen? Dilation. What's a dilation? When the pre-image, right now we got a Mario here who's the pre-image. When he hits that mushroom, he's going to grow. Ta-da! Alright, that was a dilation. Okay, so it's another geometric transformation that someone has programmed into Super Mario Brothers. That's awesome. There's one more that we want to look at. Oh, right there. We just missed it. Let's see what happens. Mario comes, hits that. Alright, so what happened to the little mushroom here? If you've noticed before, he was right side up. Alright, so they're pointed up more or less, and as Mario comes and hits him, ta-da, now he's upside down. What is that? Well, that could either be a reflection, which means he was flipped down, but I think more likely it was a rotation, where he was rotated around. But that is basic. Look, this is almost perfect image here. You want to talk one on the bottom. Okay, so...
Alright, so we saw a little bit how translations can be visualized as a video game, like with the Mario Brothers, with him bouncing up and moving over and things like that. And so we're going to now look at these with geometry. And if you take a look at this, we've got a triangle location here, and we did some of these in class where we moved the shapes around, and you were given directions. You had to figure out what the new one would look like. So we've talked about different kinds. Today we're going to talk about the translations, and translations are the ones that you move in the X or Y direction, or both. So in this case, if you look at this picture, this triangle has shifted down in the Y direction, and then it is shifted to the right in the X direction. So if you wanted to say a rule for that, you could start with your X wherever it starts, and then we move to the right, so we are going to say X. Oops, let me get the pen. X, and then we're adding however far we moved. So we moved 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be X plus 9 in the X direction. And then we shifted it down 1 in the Y. So it's just a Y minus 1. So if you wanted to find out what the new coordinate pairs would be for all of these, and we're going to say it goes to here, and then this would be our A prime, our B prime, and our C prime. So this starts at, that we said that was 8, negative 8, so we're going to go negative 8, 2 for A. We're going to go 8, 1, 2, 3, 4, 5, 6. So B is at a negative 8, 6, and our C is at 1, 2, 3, let's take it to the 3 just to keep it even, negative 3, 2. All right, so if you wanted to know what A prime would be, you're going to use this rule that we just got by seeing and looking and measuring what that translation was. So our new location is going to be at negative 8 plus 9, and it's going to be at 2 minus 1. So A prime would then be at 1, 1. And if you look at this coordinate pair right here, that is at 1, 1. And then if you look at B prime, you're going to start with negative 8, 6. We're going to add 9. We're still at 1. And then we're going to take our 6 and subtract 1, which makes it 5. And then our C prime would be negative 3 plus 9. So now we're at 6. And then we're still going to take our 2 and subtract 1, which puts it at 1. So that gives you the 3 new points of your triangle based on the rule that you established by looking at where it moved to. Okay. So the translation is, the notation is this, and you should be sure you put this in your notes because you always want to understand the notation in geometry. It's a new language and it's written in different ways, so you need to understand what they're telling you so you know what you're doing. So they're translating it this way: 6 to the left and 4 up, because it's a -6 on the x-axis and a positive 4 on the y-axis. And it's written in vector notation. That's why you now have these arrow type brackets instead of the parentheses. That's called a vector. So a vector, what that is, and you might want to stop the video now and make sure you get this written down. But a vector, it looks like this. So if we have this point, 6, 4, and we have 0. So we took the 0 point and we are translating it to 6, 4. That means we are moving it in the x direction 6 and in the y direction 4. And this combination of that movement, the direct line, you might say, of that movement, is called the vector. And the vector, here's your notation, always has an x and a y direction. So the green would be the x direction for this particular vector and the y direction for that particular vector. So it has both components, but it's written as the direct line from 0 to 6, 4, and it had moved 6 in the left and 4 in the y direction. 6 to the right and 4 up in the y direction. So if you look at this one, it's the same thing. It started at 0, 0. And we moved to 4, 3. So it moved 4 in the x and a -3 in the y. So again, in vector notation, you're getting an x and a y component. So 4 and -3. So the vector is just a way of showing the direction of the movement as well as the distance. And it's the magnitude of the vector is found by using the distance formula, which we'll talk about in a minute. So let's see what happens when the vector maybe doesn't start at 0. Maybe we're going to start it here at 2, 2. And then we're going to move it to this point. Okay? So if we start here at 2, 2, this is our initial location. And we want to know what the vector notation for this translation would be. It's just for this translation. We look at the x direction it goes, and it's going 1, 2, 3, 4, 5. So our vector translation is a 5, and then we go this, that's our vector, because now it's going up 2. So it's going to, 5, 2. So let's make sure we have the right notation here, so you don't get confused. 5, 2, there you go. All right. So now if you looked at what would this coordinate pair be, then you're looking at 2 plus 5 is 7, and 2 plus 2 is 4. Because it started, this particular translation started at 2, 2, and then it made the vector translation is 5, 2, so that gives your new point at 7, 4. Now, if you wanted to know that distance again, the magnitude of the vector is the distance from the first point to the translated point. So in order to do that, you might remember something from algebra, the distance formula. And so this again, if you don't remember this should go on your formula page in your notebook. We started a formula page with some of the area formulas, and this would be another important formula to put on that page. That's the distance is the difference in the x's squared plus the difference in the y squared, and that quantity, take the square root of it. So for our vector 6, 4, we started at 0, 0, so our x1 and y1 are both zeros, which makes it 6 squared plus 4 squared, so that's 36 plus 16, which gives you 52. And if you remember maybe we did, oops, okay, upside down division, right? And the pairs, square root of 4 is 2, and then what you have left over, it stays in the radical sign. So it would simplify to 2 square root of 3. And you could use a calculator if you wanted to find an actual distance, but this would be the simplified version, all right, of the square root. So using that same formula in your notes, why don't you find the magnitude of the vector for square root of 3 and see if, for negative 3, and see if using this distance formula, again, you can find the magnitude of this vector. You can pause the video and do that problem. So now, how would you find a translation vector for an object, not just a point, an object? So what you want to do is pick one of the points. The translation vector will be the same for any of these points. So what my suggestion is to pick one of these points, and you can just see how far in the y directions it has changed, how far in the x direction it has changed. So it's moving from A to A prime, 1, 2, 3, 4. And it's moving in the y direction to down, so that's negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be a negative 9. So if you wanted to represent your translation vector for this triangle ABC to A prime, B prime, C prime, this would be the translation vector. So you can check that by doing another point and making sure that you get the same thing, which you should. So we're going to go over and down again. So the x direction, 1, 2, 3, 4 in a positive direction, and the y, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the y. And so again, the actual vector looks like this, which is the direct route from A to A prime, and then it has an x component and a y component. Or you can look at this one, the direct route, an x component and a y component. That's one way to use the vectors, and then you could find the actual distance that it moved by using the distance formula. So take a look at this one, and it's giving you, here's the vector translation that's been done, and this is your starting point. So see if you could figure out how you would write what the new coordinate is for this particular point that's been translated using this rule. Write it in your notes, and again, we will, you can stop the video to do that and then move on. And so let's do one more. What would be the translation vector for this translation? Now remember, your pre-image is always the one that doesn't have the apostrophe or the prime symbol. So this would be the pre-image. So it's moving from here to here. And you can't just say, well, H moved to here, because this isn't H, this is F prime. So you have to match them up by their letters. So if it's E, it moves to the left, 1, 2, it looks like 3 in the left direction. So that makes your X a negative 3. And then it moves in the Y direction, again, negative 1, 2, 3, 4, 5, looks like 6. Sorry, it's a little crooked line, but negative 6. Okay, so you should check another one and make sure that you get the same thing. But the translation vector based on this, here's your actual vector, would have an X component of negative 3 and a Y component of negative 6. So the three main things you should get out of this video, the notation for the vectors is with a bracket, and this is the change in the X direction and the change in the Y direction. Change can be notated by these little delta symbols. So this is how much the change in the X and the change in the Y. So we always remember that it is positive if you're going to the right, negative for the left, Positive if you're going up, and negative if you're going down. And then a vector represents the translation in the x direction and the y direction, just like that. And then how do you find the measurement or the magnitude of the vector? We need to use the distance formula. And you can look back in the video if you need to write that down. Be sure and take the survey quiz or the survey on the Google Classroom so you can show that you watched your video. And I will see you in class.